In this lecture, we're going to explain how to find the convolution sum for linear time invariant system. So let's say that we have linear time invariant system and we have input signal x of n, discrete time type, and we have the output y of n, and the system is described by impulse response h of n. To solve this problem, to find the output for the input, first thing you're supposed to ask, what the type of the signal? It's discrete time signal. The second question, is it finite or infinite domain? What does it mean? This signal, if you have signal like that and continue till infinity, it's infinite domain. If you have signal like that and then zeros to the right, zeros to the left, so that's the domain, finite domain. So it's very important to know if it just has infinite domain or finite domain, because the method we're going to use will be different. Let's first take the case that infinite domain. In this finite domain, we are going to have an example just to show. Let's say that x of n equal to un, unit step, and impulse response 0.5 n un. It's required to find yn, and you know that yn, the output, will be equal x of n conjugate with impulse response. Since one of these signals or both, they have infinite interval, then we're going to use the sum formula. What do you mean by infinite? Let's just sketch x of n. X of n is a unit step, so at 0 you will have unit step 1, and it will continue like that. All right. So that's x of n equal u of n. And that's n at the 0, 1, 2, and continue to infinity. So it has infinite. It is not limited. Okay. The second signal, 0.5 power n un. What does mean un? Un, it means that it's only defined, this function defined only when n greater than or equal 0. So let's sketch this signal. At n equals 0, 0.5 power 0 is equal 1. So you have 1. Let's just make this one bigger like that. And that's at 0. At n equal 1, 0.5 power 1 will be 0.5. At n equal 2, 0.5 power 2 will be equal quarter, and so on. So you can say it's decreasing and 1 by 1 till it reaches 0. But it's also till infinity. It just is there, but small. That's h of n. 1, 0.5, 0.25, and so on. We said that if there is one or two, one signal or both signal, they have, or one have, infinite period, we should use the sum formula. Actually, both they have. So we're going to use that. Yn equal the sum k minus infinity to infinity, and you can use this anyone, h of k x of n minus k. So I'm going to use the sum formula. Somebody asked, can I use the other one? Which one? K minus infinity to infinity x of k, h n minus k. Yes, both are right, but I'm going to use this one. It will be easier, and you'll see why. But both are right. So what you'll do, according to this formula, h of k will stay as the same. This h of k. Let's sketch h of k. So we'll have k-axis, and that's 0. You have 1, half, quarter, and so on. So that's h of k. 0.5 n. So if you want to write h of k, you can write it like that. H of k would be equal 0.5. And instead of n, you just replace it by k. uk. And remember, this one you can write also in the same way, 0.5 k. And instead of writing uk, when k greater than or equal 0, as you see here. And we'll continue in this direction. What about the other one? The other one, we need to do some work here. xn minus k. We have xn, and if you do xk, it will be the same. Remember, it starts from 0, and before 0, everything is 0. It's a unit step. At 0 is equal 1, 1 is equal 1, and so on. To make it minus k, it will be flipped. It will be flipped out there. What does it mean? Let me show you on a separate page. If you have, that's uk, that's 0, 1, 2, and so on. So you have it 1, and continue, 1s. That's uk. If you want to make u minus k, so at 0 doesn't change, you'll have 1, but all this signal will be reflected on the other side. -1, -2, and so on. But on the right will be 0. But uk on the left is 0. So just reflection, as we know. That's u minus k. What about u n minus k? So this train of pulses, it depends on n. Like if you have n negative, like say if you take n equal -2, for example, so you are moving towards the left, so that's 0, nothing, -1, -2, you will start to see that. So that's, and 0 is here, so that's u -2 -k, or you can say it's u n minus k, where n is negative. Would be -1, -2, is just to be towards the left. If you make n equal +2, so you will be moving up to 2 and continue, and 0's this direction. What is that? That's u 2 minus k. You can write it in general, u n minus k, where n is positive. So that's how you sketch it. So we'll go back to the graph here. That's h of k. I want to sketch but different color, x n minus k. I will make it like at -2. I say this is a signal here, I have it. And 0 is here. All right. So that's x n minus k. Obviously, n here is -2. No overlap. Since there is no overlap, y will be equal 0. The out will be equal 0. If even it moved to -1, It's not. The only thing, this is n equal -2. The only thing when n reaches 0 and exceeds 0. So we'll say overlap occurs when n greater than or equal 0. The starting, if this leading pulse comes here, that will have an overlap. Before that, y will be equal 0. So that's what we're going to write. Say that when n less than 0, no overlap. And in this case, y of n is equal 0. Once we start to move the pulses at 0 and cross 0, we'll have overlap. Okay, so when n greater than or equal 0, we'll have overlap. And in this case, yn not equal 0, it will have value. Great. So when you do the sum, yn, let me write it back, sum k negative infinity to infinity, and write h k x n minus k. Of course, now we cannot make it from k equal negative infinity to infinity, because when you put h of infinity, first of all, if you look for h of k starts from 0, right? So now we're going to change this limit to 0. Why? Because h of k itself is not defined before 0. And up, if you want to find up to n, so the summation up to n. So in this case, you are going to find the sum from k equals 0 to n for this signal. Okay. Now we want to calculate it. It's very simple. What I did was explaining just to know the limit. All right. I will go and I will write what we did before. H of n was given as 0.5 n un, 0.5 n. So that was 0.5 n. Now, if I want h of k, like in this formula, I will just replace n by k. Then you ask, where is u of k? Put it there. Yeah, I know you have u of n here. I'm not putting here because I changed already the limit. That's the effect of it. Okay, what about x? X of n was given as u of n, which is 1, when n is greater than 0. All right, so x of n minus k will be u n minus k, and still will be equal 1 because we are working for n greater than 0 and k 0. So if you start from k 0, that's it will be equal 1. The value is equal 1. So now this formula, we have it there simplified to the sum from k equals 0 to n, h of k equal 0.5 per k and 1, x of n minus k, that's equal 1 because it's unit step. So I want to find the sum. That's, by the way, the right answer. But if you want to evaluate it, you can use, if you remember, the sum of geometric series. I will refresh your memory. The sum of geometric series r per k and k from 0 to n, it will give 1 minus r power n plus 1 over 1 minus r. So that will be the sum. In our case, if you look at this formula, that's your r equal 0.5. So y of n will be equal to, according to this formula, 1 minus r 0.5 n plus 1 divided by 1 minus r. Okay, we'll continue. 1 minus 0.5 n times 0.51 n plus 1 n plus 1 divided by 1 minus 0.5 is equal 0.5. So 1 minus 0.5 n, what's 0.5? That's half, right? Make it half. What's 1 over 0.5? You can multiply this by 2. 1 over half is equal to, multiply 2 times 1 is equal to 2 times 0.5 is equal 1, and what's left? 0.5 n. So the final answer, sum, will be 2 minus 0.5 power n. So that's if you have the input signal unit step going to this exponential decay, then the result will be equal to 2 minus 0.5 n. What does it mean? It means you can calculate the output at any specific instant. For example, if you want to find y when n equal 2, so you can say y2 is equal to minus 0.5 square, 2 minus quarter. That will be 1 and 3/4. So that's the value for n when n equal 2. All right. If you want to find at n equals 0, so you can find y 0 is equal to minus 0.5 power 0, 2 minus 1 is equal 1, and so on. So you can get it at any time. I hope that was clear, and we'll see you in the second